Hey guys, good morning. Hope you're having a good day. We are ready for our ELA lesson for today. Are you ready to read our story for this week? We read about those apex predators yesterday. Okay, we get back at this. I had a phone call. Sometimes that happens. Sometimes parents call and want to tell me the internet's not working or something like that. And that's fine. I appreciate your parents keeping me updated on everything going on. But we're ready to read our story for this week. Yesterday we read that big story that's kind of the focal text for our writing called Apex Predators. Remember, our whole theme this unit is talking about our senses, as apex predators use their senses to hunt, and or the prey use their senses to hide, right? So today's story is called The Science Behind Sight. How can we see? How do our eyes allow us to see things? And we've got 5 vocabulary words here we need to look at and understand that are going to be in our story. And so let's go over them today. And the first one is luminous. Luminous. A luminous object is something that gives off light. So anything that gives off light, you would call it luminous, like the sun is luminous. We're going to look at this word later on. You probably can think of some words that are related to this word that I think about light, like illuminated or something like that. Some that sounds kind of like luminous. If something is illuminated, it means the light is shining on it, right? So, or it's giving off light itself. A luminous object is something that gives off light. Transparent, that's going to be a science word that we'll learn this year when we talk about light. Transparent, if an object is transparent, you can see through it. A window is transparent. It's good if some things are transparent. We want windows to be transparent because we want to see through them. What else would we want to be transparent? Maybe a glass that we're drinking from, or my water bottle is transparent so I can see the water that I'm drinking, how much is left. What are some things we wouldn't want to be transparent? We wouldn't want our walls of our house to be transparent, would we? You wouldn't want your shoes to be transparent. Everybody be looking at your toes. So transparent, you can see through it. Reflect. When light reflects off of a surface, it bounces back without passing through the surface. This is another science word we'll be learning this year. So it's like your mirror. You can see yourself in a mirror because light bounces back without going through the mirror. You see your what? Reflection in a mirror. So that's the light that's on you bouncing off the mirror and back into your eyes, a reflection. It's when light bounces off a surface, reflects off a surface. Illuminates. Well, look here. That's kind of like luminous, isn't it? Luminous, illuminate. You see that L-U-M in both of them, L-U-M-I-N. Something that illuminates gives off light and makes the area around it brighter. A lamp illuminates the area around it. And then judge. If you judge, you guess or estimate the size of something. You might judge the weight of an object before you try to pick it up. And those are your only 5 vocabulary words for this week. We'll practice them tomorrow in an assignment. Today, just want to introduce them to you as we read the story together, okay? But you'll need to know these this week. Let's go to our story. And as I said, it's called The Science Behind Sight. And this story, I believe I mentioned it yesterday, is an informational text. An informational text gives facts and examples about a topic. So this is not like Kitoto the Mighty. Whoops. This is not like Kitoto the Mighty. Sorry, didn't mean to do that. This is different. It's not a fictional fable, folktale. This is like science, learning facts, or maybe social studies would be a type of informational text as well. Authors of informational text often organize their ideas using headings and subheadings to tell the reader what each section of the text is about. Think about our story we read yesterday about apex predators. Like one side of the page would have maybe predators of today. The other side would have the heading extinct predators. So they had headings at the top of the page to help us see what we were looking at. Science texts include specific words about the topic. Informational text often include visuals, such as charts, diagrams, graphs, and maps. I think we'll see some of those in our story for this week. So let's take our first look at the science behind sight. And this is in your book, okay? In your book, page 107, if you want to turn there with me, please. Page 107, the science behind sight. My pages are so big, I wish I could shrink them somehow. Let's see if I can do that so that we can all read this together. Zoom out. Can I do it again? Zoom out. Well, I can't. It's a little better. All right, seeing things. Think about how you are reading the words on this page. You can read these words because your eyes can see. Seeing things help us find out about the world around us. The sense of sight. We have 5 senses to help us understand our world: sight, smell, touch, hearing, and taste. Sight is very important. It shows us sizes, shapes, and colors. It tells us where we are going and how far away things are. It helps us read, play, learn, watch things, and more. Light and dark. When we can see when it is light, but it is hard to see well in the dark. When we go into a room with no lights or windows, it is dark. The room and the things in it look black because there is no light to help us see. Down here at the bottom, light gives us sight. We can see the trees in this forest because of the sunlight shining on them. So we learn from this page we've got to have light to see, don't we? You can't see anything in the dark. So remember it talked about headings? The heading on this page is called Seeing Things. Then subheadings are like these, smaller, and tell you about what this paragraph is about. So our first page tells us the first thing we need to know about sight. If you're going to see anything, you've got to have some light. Light and sight. When it is dark at bedtime and you want to read, you turn your lamp on. We use light from lamps to see when it is dark. Luminous things, there's one of our words. Things that give off light are luminous. Look at the context clue there. It tells us the definition in the sentence, doesn't it? Things that give off light are luminous. The sun is luminous. We use light from the sun to see things during the day. Lamps, fires, televisions, and flashlights are luminous too. I use my flashlight on my phone sometimes, don't you? It's luminous. It gives off light. Making shadows. Light from luminous objects travel in straight lines. It can move through clear things such as air, water, and glass. This is how windows let light inside our homes so we can see. We say clear things are transparent. So there's another context clue here, isn't it? If you don't know what transparent means, what are they? They're clear things clear things are transparent. If you close your curtains, you stop light from getting inside. The curtains are, look at that word, opaque. Opaque things do not let light through. So look at the wall in your house. No light is coming through the wall. It's opaque. But look at your window. Light is coming through because it's transparent. And when light cannot pass through something, it can create a shadow. So look here at the window. You see the lights coming in through the transparent glass, and it shines on into the house. But look at the pattern on the floor there. Do you see the little things on the floor there? What's making that? That's these in the window, isn't it? They are not transparent. They are opaque. So light can't shine through them. So it's making a shadow on the floor. Also, light can't pass through a tree. So what does it make? A shadow on the ground under the tree. Reflecting light. We see things when they give off light or when light bounces off of them. So look at this little boy. He's looking at his computer, it looks like. The light from here is shining on there and here, and it's going into his eyes, and it gives off light itself. Your screen does, doesn't it? We see luminous objects because they give off light. However, most things we see are not luminous. Tables, chairs, soccer balls, and fields do not give off light. Instead, they reflect it. Light bounces off surfaces and objects around us, and we see them when some of that reflected light enters our eyes. My sister asked my dad a funny question one time, and she was about second or third grade. She said, "Dad, what's more important, the sun or the moon?" And he said, "Well, I'm not sure. What do you mean? Why?" She said, "Well, I think the moon is more important." He said, "Why do you think the moon is more important?" And she said, "Because the sun shines during the day when it's already light, but the moon shines at night when it's dark." What was she wrong about? Why is it light in the day? Because the sun's shining, right? And why does the moon shine at night? Do you know? The moon does not give off any light. The moon is not luminous, but it does reflect the sun's light. That's what causes the moon to change shapes, because it's at different angles from the earth, where the sun hits it at different times of the month at different angles, and so only part of it lights up. But it doesn't light up itself. It reflects the light of the sun. Did you know that? More light, more sight. We can see better when it is lighter. When you are in a dark room, a candle illuminates. Remember, illuminate means give off light. Only a small area. But if you turn on a ceiling light, it lights up the whole room. Some surfaces reflect light better than others. Black fabric does not reflect light well. Light reflects best off of shiny surfaces, such as mirrors. Light's only a small space. If you want more light, you have to light more candles. How eyes work. An eye is shaped like a round ball. Most of it is inside your head. Do you know what the outer parts of the eye, the parts that you can see, do? We're about to find out, I have a feeling. Eye care. Eyelids can close quickly. Blink your eyes to protect your eyes. When an eyelid blinks, it washes the surface of the eye with tears. Tears wash dust and other things off the eye. Tears leave your eye through a tiny tube called a tear duct, letting light in. The colored part of your eye is the iris. What color is your iris? Is it blue or green, yellow, brown, black? The black spot in the middle of the iris is an opening called the pupil. So right here in the middle. See, the colored part's the iris. The black part in the middle is the pupil. The pupil lets light into the eye. In bright light, your eye needs to take in less light, so the pupil becomes smaller. In low light, the pupil becomes bigger to take in more light. Did you know that? So inside your eye, this black part, it actually gets bigger and smaller based on how much light you need. In a dark room, it's going to be really big, trying to find all the light it can. But if you're out in the bright sunshine, it's going to be smaller, so too much light doesn't get in and give you a headache. Look at your eyes in a mirror and then close them. Open them quickly to see your pupils getting smaller in bright light. You can try that if you want to. Close them and then open them while you're looking in a mirror, and you'll see the pupil in your eye changing size. Here's the outer part of the eye. You got your eyelid. It's the part that closes, washes your eye, we read. The pupil's the black part in the middle. The iris is the colored part around the pupil. And your tear duct's over here in the corner. Looks kind of gross, but that's where our tears come from. Okay, let's read this page. Light and lenses. Light passes into the eye through a lens. A lens works a bit like a magnifying glass. When you look through a magnifying glass, it makes things very clear. In the same way, the lens focuses light so the image that we can see is clear. It focuses the image onto the back of the retina. The retina is the surface at the back of the eyeball. The image that the lens sends to the retina is upside down. The brain turns it the right way up. So we know what we are looking at. Let's look at a diagram of that. So light from an object passes through the lens, here's the lens, of the eye and is focused on the retina just this back part right here. All right. So here's a tree. If you were looking at a tree outside, the light is shining on the tree, and so the light comes into your eye through the pupil and goes through the lens, and the lens makes it back upside down on the retina, but then these nerves that go to your brain turn it the right way up so you can tell what you're looking at. Isn't that interesting? Let's look at the next page. Messages to the brain. The retina sends messages about what your eyes see to your brain. First, it changes the colors and shapes in the image into millions of signals. Then it sends these signals to the brain along pathways called the optic nerve. The brain figures out what the signals mean. Lens and distance. Look away from this book and focus on something far away. You will not feel it, but the shape of your lenses changes. The lens becomes thinner when the eye looks at things close up, and it becomes thicker when the eye looks at things far away. Isn't that amazing? If you're trying to look far away, the lens part of your eye automatically gets thicker. So it's like a magnifying glass. You can see things farther away. When you're looking at things up close, it's thinner. Isn't that amazing that our eyes can do that? Our eyes are amazing. When you look at things far away, the lens in your eye changes shape. How about animals? Animal sight. Some animals see the world in a different way than we do. Our eyes are on the front of our heads. Rabbits and horses have eyes on the side of their heads. What's the difference? Well, if you have eyes at the front, close one eye and try to touch the ends of two pencils together or your finger. Why is it so hard? Can you do it? With one eye, you cannot judge exactly how far away things are. With two eyes at the front, each eye sees a slightly different view. The brain compares the two views to figure out exactly how far away something is and how fast it is moving. So you can judge distance a lot better when both eyes are open. You don't drive a car yet, but sometimes I have allergies, and when I'm driving my car and maybe one of my eyes starts to water and I have to close it, maybe use my sleeve to wipe the tears away to try to see clearly, I get scared driving because I can't judge distance as well with only one eye open. So I have to be very careful. A lion's eyes see what is straight ahead of it. It's got eyes on the front of its head like we do, so its field of vision is like ours. Okay, let's look at this other side. Foxes, lions, and most other predators, animals that hunt other animals, have two eyes on the front of their head like us. This helps them to hunt and catch animals. You cannot judge distance very well with just one eye. Try playing with a ball with one eye shut. You'll find that you're more likely to get hit by the ball than catch it. Be careful not to hurt yourself. Animals with eyes at the side. Animals with one eye on each side of their head can see when a predator comes up behind them. The downside is that these two eyes work separately. Because the images the two eyes see are so different, the brain cannot compare them to figure out exactly how far away things are. So, since his eyes are on the side of his heads, he can kind of see further back than we could. He can see kind of behind him. His field of vision is bigger. The water buffalo can spot things moving on all sides. Seeing at night. A cat's eyes glow in the dark because they have a part behind their retinas that work a bit like a mirror. It reflects light back onto the retina. Because more light is reflected onto the retina, the cat can see more. That is why cats and some other animals can see better in low light than we can. So they've got a special part in their eye behind the retina, kind of like a mirror, and it collects more light. Pupil power. To let more light into your room, you open your curtains wide. When it's nearly dark, cats' pupils open very wide to let in as much light as possible. In bright light, their pupils are very narrow. This stops their retinas from being hurt by too much light. If you have a pet, have you ever come home and seen it looking like this? It looks a little bit creepy. Its eyes are glowing. They're not really glowing. They just have like that special part behind their retina that's like a mirror. So all the light that's coming in is reflecting back, and it makes them look like they have glowing eyes, which is kind of creepy, isn't it? Can you tell which of these cats is looking to bright light and which is looking into low light? Well, in bright light, your pupil would be smaller, and in a low light, your pupil would be the biggest so that you can get more light in. Wearing glasses. Do any of you wear glasses? I have to when I'm driving. Some people wear glasses to help them see clearly. People who are nearsighted can see things that are close clearly, but things farther away look blurry. That's me. I'm nearsighted. I can see up close really well, but when I try to look at things far away, they look blurry. People who are farsighted can see things that are far away clearly, but things up close look blurry. Wearing glasses help these people to see better. Refraction. Put a straw in a glass of water and look at it from the side. At certain angles, the straw looks broken. That is because the water in the glass bends light as you are looking at it. Bending light is called refraction. I don't have a picture of it here, but you can try it sometime. We'll watch a video about it this week too. The lens in your eye refracts light to focus in on the retina. Sight problems happen when a person's lens does not refract light onto the retina properly. So our lens in our eyes, that part that gets thicker or smaller we looked at, it helps focus whatever we're looking at on the retina. When our lens doesn't work correctly, we've got to put another lens in front of our face, like these lenses, these glasses. How do glasses work? Glasses and contact lenses work by refraction. Lenses and glasses are made from pieces of transparent plastic or glass. The pieces are curved so the lenses can be bent, can bend light. Lenses bend light to focus it on the right spot on the retina. This allows the wearer to see clearly. So when I go to my eye doctor, he puts different kinds of lenses in front of my eye with a little machine, and he'll switch. How's that? And I'll say, still blurry. How's that? I can see better. And he'll know it's the right kind of lens I need because it's focusing the light correctly on my retina to help me see things more clearly. If you're nearsighted, the lens focuses on the image. The image is on the front of the retina. Okay, so, and if you're farsighted, the lens focuses the image behind the retina. So nearsighted, what did it say over here? You can see things close clearly, but things far away look blurry. So that's my eye right there. So it focuses the light a little too far away in front of the retina. It needs to be on the retina to be clear, but it's not in my eye. It needs to go back a little farther. So I put my glasses on, which sends the light back, focuses it in the right spot. Some people are farsighted. They put glasses on to read a book maybe because things up close look blurry, but things look far away look clear. Well, in that case, the lens is focusing the light too far back behind the retina. So their glasses would bring the focus more closer to where it's supposed to be. Concave lenses. Concave lenses bend the light outward to help the lens focus the image on the retina. So concave, it's curved inward as a concave lens. Okay, it focuses it inward or outward. You see it sends it out that way. Convex lenses bends light inward, so it's coming in and it bends it in to help the lens focus the image on the retina. So those lenses change the focus to help us see things better. Make a pinhole camera. Here's a little project you can do if you want to try it. You need a clean potato chip tube, like Pringles with a plastic lid, scissors, thumbtack, wax paper tape, aluminum foil. Ask an adult to cut 2 inches off the bottom of the tube, then use a thumbtack to make a tiny hole in the center of the bottom of this short piece, like it's the pupil of your eye. It's a little hole to let light in. The plastic lid at the other end of the tube will be like your retina. This is the part the image will hit. Put a piece of wax paper over the lid, then put the lid into into the short piece of the tube. Put the longer piece back on top and tape these pieces together. To keep the light out of the tube, wrap a piece of aluminum foil twice around the tube and attach it using tape. Outside on a sunny day, close one eye and hold the open end of the tube to your other eye. Do not look directly at the sun. Keep the inside dark by holding your hands around the end of the tube by your eye. You should see a picture of the object you're looking at on the lid. It will be upside down. This is what your retina sees before your brain turns the image the right way up. So that's on page 122 of your book. If you want to try to do that, make you a little pinhole camera. All right, so we'll end our lesson there today, and we'll go back and review this some more tomorrow. I'm going to let you read it on your own, and I believe we'll watch a Bill Nye video tomorrow on sight and light, so I think you'll enjoy that. Today, what I want you to do, after we do one little activity here, is spelling practice. Go practice your spelling words, and we're going to work on sentences again. So those will be your 2 assignments to do today. But before we go to them, let's look at one more thing here. Let's talk about summarizing. Summarizing. I don't know why my pages have decided to be so big. That's not what I meant to do. Okay, Mr. Helton. There we go. That's better. But where am I? Am I on the screen anywhere? I don't know where I have gone now. Okay, Mr. Helton, where are you? I guess I'm here somewhere. I just don't know where I am. So let's look at this together. Summarizing. When we're summarizing a story, we find the headings and subheadings. We looked at them together. We find the main ideas. We remove unnecessary information. We remove repeated information. And we replace lists with general wording. And then we write short topic sentences. And we combine topic sentences into a short summary. So if we were going to summarize the story we just read, what would we do? Well, we would talk about the headings and subheadings. We could say it talks about how we see with light, how our eyes work, how animals see, how different places on your eyes being on different places of your head cause you to see differently. We could find the main ideas of it, that we have to have light to see, that we could find information about the pupil and the retina, some of those main ideas. The parts of the eye would be a main idea. Animals' eyes would be a main idea. We could write short topic sentences if we were going to summarize it in a paragraph, and we could combine it into a short summary. We'll be doing some summarizing, some during the year. So here's some ways that you can know how to summarize. All right, go do your assignments now, and we'll see you tomorrow.